Hearing works by sound waves entering the auditory canal and reaching the tympanic membrane. The sound waves vibrate their way through the middle ear, consisting of the bones, the malleus, incus, the stapes, which then translate that energy to the inner ear where it reaches the hairs within the cochlea. The vibrations that are picked up in this region trigger signals to be released that travel to and processed by the brain. The most common way hearing is damaged is through loud noise. Due to the powerful sound waves, they damage the hairs that line the basilar membrane of the inner ear. Over time, long-term exposure eventually causes these hair follicles to collapse and fade, which affects hearing. Risk factors for hearing loss and damage can include the most common way people damage their ear, which is loud noise in environments such as concerts, clubs, or construction sites, or simply listening to loud music. Many studies, as done by Chigan et al., showed that workers that are exposed to loud noise have much increased risk of developing hearing loss. Thankfully, there are some methods for assisting those with hearing loss, one of which are cochlear implants, which is suggested for those with severe hearing loss, essentially replacing the function of the inner ear responsible for providing the brain with electric signals.
The cochlear hearing aid consists of internal and external parts which work with one another to feed information directly into the inner ear. A microphone picks up raw sound from the environment. This sound is then fed into a sound processor, which converts the sound into raw digital information. The converted digital information is then fed into the transmitter antenna, which transmits the data through the skin to the internal implant receiver. The internal implant then converts the data into electrical signals. These electrical signals travel down a wire which feeds into the inner ear, or otherwise known as the cochlea. It is inside the cochlea that the transmitted signals cause the electrode array to generate impulses. These impulses ultimately stimulate the auditory or hearing nerve, which sends the information to the brain, which interprets it as sound.
The one and only advantage of having a cochlear implant is that you can hear bilateral sound for the first time. This advantage multiplies into different sections, being able to distinguish different kinds of sounds, able to use different volume pitch while speaking, easier to hear voice from phones and TVs, and being able to hear your own voice and being able to control it.
Disadvantages of cochlear implant is associated with the risk of procedure. Problems like bacterial infection and implant rejections are very common. Ringing of the ear, taste disturbances, and vertigo could arise and result to damages to the auditory or the facial nerves. The cost of the implant is one of its major problems. The added expenses of the surgery, the device itself, and the post-operative care can easily cost well over $50,000, and because of this, most patients cannot afford to get cochlear implants. Other disadvantages include the limitations and maintenance. Patients will be inhibited from physical sports and water-related activities. Limitations of sound transmission is a common disadvantage for adult patients. Maintenance such as remapping of processors, replacement of wires, and battery changing are often required.
Rising awareness and adoption of the implants to remedy a wider variety of hearing disorders has prompted more research and further refinements into implants. In 2016, Cochlear launched the Nucleus Profile implant, which features a thinner electrode that occupies less room of the inner ear that minimises the chance of damage to the ear whilst delivering a clearer sound to the patient. Other developments related to advancing the hardware of the implant look at converting sound into light energy for transmission to the brain as opposed to using electrical signals, which aims to provide a much more clearer sound. However, research has only been successful on rodents so far. Other research focuses on improving brain perception of sound from existing implants through computerized training. For some patients, the sound emitted from the implant can be more of a nuisance as the sound is heavily distorted. As such, most patients will still heavily rely on sign language to communicate. Researchers at the Rush Auditory Research Laboratory have been testing computerized auditory training to better improve the sound heard by patients. This is done by exposing patients to a variety of challenging sounds, which trains the brain to fully interpret information about the sound their implants are providing. The end goal will see both speech and environmental sound perception improve. Despite the invasive surgery and heavy costings associated with fitting a cochlear implant, The quality of life granted to a patient far outweighs these negatives. With developments in brain perception of sound and conversion of sound to an alternate signal, the cochlear implant will continuously evolve to benefit a wider demographic of patients and will eventually emit sound indiscernible to a healthy ear.